Hello everybody, this is the first tutorial. They're not in any particular order, at least some of them aren't. This one's not in the first in order, it's just the first tutorial I've made for my first person RPG demo. Ultimately, my goal personally is to make a game similar to the old Might and Magic games. Might and Magic 6, The Mandate of Heaven came out in 1998. It was one of my favorite games when I was in high school, and I'd love to make a modern game very similar to it with a lot of the similar gameplay aspects. And so this first tutorial is based on that. In fact, this whole demo is going to be based on creating this type of game. InfinityPBR.com is the website. Infinity Series is the name I've given to my work here. I've been producing with some talented artists some really killer models and animated models and weapons and objects that you can use for your games. They're all on the Unity Assets Store. If you've got any questions about any of these, connect with me on the forums. All the forum threads are here, and you can easily find my send me a private message, or better, if it's a public question that other people might be interested in, just ask it on the forums and I'll get back to you. The scripts tutorials are more at the bottom here. There will be a section for this this whole first-person RPG listed here when I get finished with this first video. So let's go ahead and check out what this does. Might and Magic 6, one of the key features is that there's a calendar, and the game takes time. And as you play the game, every, I think about 2 seconds, 1 minute passes in the game. However, it also has turn-based action. It's a first-person game, but there's a lot of spells, a lot of weapons, and it's not something where you press a button and just hack and slash your way through hordes of enemies. Instead, hordes of enemies will surround you, and you go into a turn-based mode in order to actually fight. Because of that, the game clock needs to be able to pause, and it would have to pause otherwise for game menus and whatnot. And so I wanted to create a very simple and lightweight method of doing this time control thing. So if you open the package and put in your project, you'll notice it's buried here in SFA Studios, SFB, Game Templates, First Person RPG, and then you'll find prefab scene scripts and textures. Right now we really only have the scenes, the time controlled test, which is the scene we're in right now, and our scripts. If you have any of our other demos or any of our other models, we keep the same format and it's the same metadata. So the best bet with these assets is to never actually move them. I do keep them hopefully in a well-organized state for you, so that I only take up one spot in your main assets folder for all of my stuff. So if you have all the different models, it stays organized. There's also, for the models, shared files that work between all the models, and if you don't move anything, then you shouldn't run into any installation issues for any of the models or any of this stuff. Ignore the temp hold, that's for my own purposes. So let's go ahead and look at the scene, see what we're doing here. So this script is basically calling up the time since the game started here. If we had saved the game, perhaps we would have saved this with a higher number from wherever we saved it. And every 2 seconds or so, it increases the minute counter by 1. Eventually, that will increase the hour counter, the day, the month, the year, and so on. This will switch to PM, afternoon. And if we open a window, it pauses. Close it, it starts. Also, if I hold down the T key, then it pauses, and if I lift that up, it stops. Now, also, I can hold down the T key, pause it, open the window, let go of the T key, and it's still paused because the window's open, and we'll close that. So let's go through and see how I'm accomplishing this. One thing to remember is I am not the best coder. I change things a lot. Every time I do something, I get better. So this may not be the best way to accomplish the goal set at hand. It is one way. It seems to be working for me. I found a couple bugs already while doing this video that I deleted and adjusted and then re-recorded the video for. So keep all that in mind. I'm not the best coder, but this is hopefully going to be helpful to people who were like me a couple years ago and even worse than I am now, or just looking for a new way of doing something and making use of the Infinity Series models. So let me expand this. Our first static variable, static because I want to be able to call it from other scripts easily without having to link directly the object is time code. Now that's this code right here that you saw in the second line. Time code is basically the time since the game started. Call for pause is an integer. This is going to increase by 1 every time a script says I want to pause the time control. Stop recording time. It's going to subtract by 1 every time any of those scripts allows the game to be released. As long as this is 0, time will be recorded. If not 0, then it will not increase the time. In-game time multiplier rather, is how much faster the in-game time is versus real life. You can adjust it as you'd like. This is a variable you can adjust right here on the time controller object. I have it set to 30. You can adjust it as you see fit for your purposes. The next chunk of code here, or variables, is static variables for game, second, minute, hour, day, month, year. These are the actual in-game variable values. So this is what I've set to for the game start, 8 a.m. on May 1st in the year 3293. If I were to be loading a game from a saved file, perhaps in the start function, I would get the time code variable or float that I've saved and compute these values based on that. So the start of the game is a different value. It's actually this saved values, and these are the variables we'll call in order to update the text in the game for displaying the date. The last section is seconds per minute, minutes per hour. Pretty self-explanatory. It's the number of seconds per minute, etc. I've got 60, 60, 24 for the minute, hour, and day. I'm setting it to 24 days, or 28 rather, 28 days per month for easy math, 7 days per week, and then 12 months per year. So there's only 48 weeks per year. We do cut off some days versus our human year here on Earth, but for the game, it's a lot simpler just to keep every month at 28 days. Nothing in the start function at this point. In late update, we update the time if call for pause equals 0. We'll get into that in a little bit. Update time does very simple things. The time code gets increased by delta time of the frame. The game second is increased by delta time times the in-game multiplier. Now this is of course the in-game world second, what second it is in the game's world. If that second is over seconds per minute, we'll increase the minute by 1 and reduce the second per minute by seconds per minute. One caveat here, if you increase the in-game multiplier so fast that every frame this goes up, game second goes up by over 1 minute, the total process of increasing time will be capped at 1 minute per frame, because this only subtracts 1 minute rather than say 3 minutes if the last frame you added 3 minutes worth of seconds. In most cases that's perfectly fine. If you for some reason need to increase the ability to have the multiplier go to super high levels, then you'll need to redo the code for your own purposes. So each other section does the same concept for the minutes, hours, days, and the month to increase the year every time the month goes beyond the number of months per year. So that's attached here to time controller. This is an object that we would keep in the game throughout. Our debugger script has an array for the months. They're listed here, January through December. Let's load that up. And the other variable is just time display. This is a link to a game object. In this case, it's our text for displaying the time in our UI panel. On update, we're going to update time display, which does we create an empty string, populate that string with the month, day, year. This is time string. I just want to separate into 3 lines so it's not one really long line. Time string space between the days, and then we got the hour, colon, minute, and the meridian. That's AM or PM. I'm not sure if I'm spelling that right, but c'est la vie. Last one is /n. If you don't know this, /n will add a new line. It's a carriage return in the text field, so that's a handy tool to remember. And the time code. Lastly, this last line, time display, get component UI text equals the time string that we just computed. These fixed month, fixed hour, fixed minute, and meridian are functions that return things. A string, int, string, and a string. Fixed month simply returns the string of the month from our array up here. Fixed hour computes whether or not it should be 12 or that's if it's because we can keep the code in army time 0 through 2300 hours. If it's 0, we want to fix that to be 12, so that we can say it's like 12:30 a.m. And if the game hour is over 12, we want to switch it from army time to civilian time. So we'll just say game hour minus 12. And if not, then we're just going to keep fixed hour equals game hour, return that string. Similar for the minute, we want to add that leading 0 if the game minute is under 10, otherwise leave it as is. And the meridian, it starts as AM. If the time game hour is greater than or equal to 12, then we'll switch that to PM. Pretty simple script there as well. The only other thing that we need to look at is just the buttons here and what they do. Oh, I guess I did skip over that. This is the code for the get key down T. Whenever the T is pressed down, this only gets called when the button is pressed down, not every frame. Time call for pause goes up by 1. When you get key up, T, call for pause subtracts 1. The other thing we have to look at here is this panel. This is our window. It's set to be inactive. It has a script that says pause while active. Just like the T, whenever this is enabled, whenever it turns on, call for pause is increased by 1. Whenever it gets disabled, call for pause decreases by 1. That way, when we enable the window by pressing open, call for pause now equals 1. If I hold down T, the key T, you'll have to trust that I'm pressing it down. Now call for pause will be equal to 2. When I close the window, that will subtract that by 1, and it's still 1. Therefore, since it's not 0, time isn't on. But if I let go of the T button, it goes to 0 again, so time can go on. Now, it's important to keep that in mind whenever you do anything with pausing the time, to make sure you do the correct logic for starting it up again. Our buttons here are to open the window. It only does 2 things. It sets the panel object for the test window to be active, and it makes the button itself not interactable. The closed window does the opposite. It sets the panel to be not active and sets the button to be interactable. That way you can open the window, close the window, open the window, close the window. And the panel time doesn't do anything but display the time. That's pretty much it. None of this stuff is too mind-blowing. It's pretty simple though, and it's important for games like this. Hopefully there's something in here, if you watch the whole thing, that will work for your game. If you have any questions, please let me know on the forums. If you like this series that I'm doing, please tell other people about it, and go to the forums and comment on my threads and stuff, because that helps get the word out, and the more people who check it out, the more likely I am to keep making more. So enjoy and happy game making.